We have, thank you, turning on the recording. We have 5 minutes, most of which we've used already for the opening remarks. Do these updates on projects in about a half hour, have a 50-minute open discussion, and then closing remarks. We've got an hour and a half allocated for the meeting. So without further ado, I'm going to turn it over to Nicole to present the slides.
The PFAS testing at POTWS study examined the presence of PFAS at all 114 NPDES POTWS across the state. The report presents, excuse me. The report presents data on PFAS entering POTWS, the influent, leaving POTWS, the effluent, and in wastewater sludge. Data included samples collected for this study in 2025, as well as data from permit-required monitoring. PFAS was tested in 3 ways, which we will describe in more detail on the next slide. The study is publicly available through mass.gov/DEP.
Nicole, your audio is a little quiet when you lean back. If you're able to lean forward more, I think we're going to get a clearer.
Oh, okay. Thanks.
Clearer voice.
Three different PFAS test methods were chosen to measure specific compounds, to approximate all PFAS, and to compare to permit data. The methods included EPA method 1633, top assay, and AOF, or adsorbable organic fluorine. The Venn diagram on the right shows how each of these test methods relate. AOF is the broadest method, which gives one aggregate result for all PFAS in the sample. Next is top assay, followed by method 1633, which measures concentrations of 40 PFAS compounds. EPA method 1633 tests for 40 specific PFAS compounds in wastewater matrices. It cannot measure every PFAS compound that exists, of which there are thousands. NPDES permits also include requirements to test for PFAS using method 1633, so the study data can be compared to permit compliance data. Top assay, or total oxidizable precursor assay, is a process that helps find PFAS that method 1633 might miss. It works by turning some hidden precursor PFAS into measurable compounds and then measuring using method 1633. And the last test method is AOF, or adsorbable organic fluorine, which measures organic fluorine, a key chemical found in all PFAS. It offers a broader picture by capturing all PFAS types and compounds. AOF results represent an aggregate measurement of all PFAS in the sample. NPDES permits include requirements to test for AOF using EPA method 1621, so study results can be compared to future permit compliance data. The major conclusions from the study are listed on this slide. Number 1, PFAS is widespread in wastewater and sludge. PFAS are present in wastewater received by wastewater treatment plants. The wastewater comes from industries, including landfill leachate, commercial, institutional, and residential sources. This study detected PFAS in most wastewater and sludge samples. Number 2, the standard method for measuring PFAS misses a large fraction of PFAS in wastewater and sludge. AOF results for influent and effluent samples were much higher than the PFAS results from method 1633. This is expected because AOF may capture PFAS compounds that are not analyzed using method 1633. Sludge samples had the most conversion of unmeasurable to measurable PFAS compounds after the top assay process, compared with influent and effluent. And number 3, predicting which POTWs receive large industrial PFAS contributions is not straightforward. Because of this, identifying PFAS sources must be done on a facility-by-facility basis. The study analyzed 2 possible shortcuts to identifying which POTWs have high PFAS contributions from industries, whether a facility has an industrial pretreatment plan, and whether a facility has contributions from specific types of industries. Having a shortcut could help time and cost effectively direct PFAS reduction efforts. However, these shortcuts were found to not be reliable predictors. Instead, to perform effective industrial source identification, you need to analyze individual POTWs for upstream PFAS contributions. Number 4, the study suggests ways to improve PFAS data quality for future analysis. MassDEP is using these recommendations to develop guidance documents that we will discuss on the next slide. Next slide, please. In response to the study, MassDEP has worked to develop guidance documents to improve PFAS data quality and reliability. The guidance for facilities addresses common questions around permit compliance and PFAS sampling. Some highlights include a recommendation to discuss the optimal sample size and number with the lab, take grab samples instead of composite samples, test sludge as a solid whenever possible, especially above 2% total solids, and to include J-flag data. These draft documents are currently under internal review and will be posted to mass.gov once completed. Thank
you. I got a logistics question to ask the staff. I'm not sure which, I've got multiple screens, which slide screen is being shown at the moment? Because I thought somebody else was advancing the slides.
It's the last PFAS at POTWs slide.
Okay, so that is, and now we're Sludge Study Part 1, and that's you're up, right, Whitney?
That's it. Thank you, Alden.
Okay, good. Good.
Right. In 2024, MassDEP was provided with funds to evaluate sludge disposal capacity, factors affecting sludge disposal, and PFAS reduction and treatment technologies. The study, which I will just refer to as the Sludge study, was divided into 2 parts. Part 1 evaluated the current and near-term destinations for Massachusetts sludge and septage. Many utilities and stakeholders have participated in the survey that accompanied Part 1, and we are grateful for your participation in the efforts to make the information contained in the report as accurate as possible. Part 1 was completed in 2024 and is available on the MassDEP website. Part 2 focused on the intersection of sludge and PFAS, including how legislative and policy decisions regulating PFAS may affect sludge disposal capacity and PFAS reduction and destruction technologies. The Part 2 report was completed in 2025 and is also now available on MassDEP's website. Next slide, please. The goal of Part 1 was to map current and near-term sludge and septage disposal management in Massachusetts. This was achieved by compiling quantity and cost information for the 3 main current disposal options for sludge produced in Massachusetts, those being landfill, land application, and incineration. In previous presentations, you may have heard this concept referred to as the 3 legs of the stool, the idea being that the stool would fall over if any leg were to be completely removed. The goal of Part 2 was to consider the future options and associated costs of managing wastewater sludge that contains PFAS. Part 2 includes an evaluation of how legislative and policy decisions for regulating PFAS could affect sludge disposal capacity, the contributions of PFAS into POTWs due to indirect discharges, PFAS reduction and destruction technologies, a series of sludge disposal scenarios and analysis, and options for the state and POTWs to consider moving forward.
Whitney, before we advance.
Yeah, it sounds like there's a presentation issue in the chat.
I just wanted to check in. Do we have others who are not seeing the presentation? Okay. Okay, Amy, it seems like it might be on your end.
Amy, if you don't mind putting your email address in the chat, Jennifer or Kaylee could send a copy, email a copy of the slides so that you can follow along with us. Okay, let's see.
Yeah, we're still on the part 1 slide, responding to the conclusion slide. Whitney, let me know when
Okay,
you're
so we're on
ready to
slide 9?
advance. Okay?
Okay. Oh, I might have been speaking over the wrong slide. I apologize if I did that. Anyway, the main takeaway from part 1 of the sludge study was that overall, we're seeing a decrease in capacity in landfills, land application processing facilities, and incineration facilities. There was also significant concern over availability of the Woonsocket incineration facility to accept Massachusetts sludge in the future, which we now know Woonsocket will no longer accept liquid sludge as of 2027. Another major takeaway from part 1 was that with sludge capacity decreasing, an estimated 12,000 dry tons of sludge will not have a clear outlet by 2028, and overall, the landscape of sludge management is facing increasing pressure. Next slide. And the main takeaways from part 2 were that we are seeing conventional sludge management options like incineration, land application, and landfilling becoming more limited within and outside of Massachusetts. Since data was gathered for the report, Connecticut has banned land application, the Woonsocket incinerator stopped accepting liquid sludge, and the Hawk Ridge composting facility stopped accepting product in August of 2025. There are a few paths forward, including expanding existing sludge management capacities, additional sludge volume reduction, reducing PFAS at the source, and developing new facilities to treat for PFAS. The sludge management system is complex, and there's a role for treatment plant operators, regulators, and legislators who can all take specific action to help extend available disposal capacity and support PFAS reduction and destruction technologies. And now I will turn it back over to Weldon to talk about where we are headed next.
Thank you, Whitney. So one of the recommendations from the sludge study was to facilitate piloting and support funding of full-scale projects of emerging technologies. In response to this recommendation, MassDEP has commissioned a study called the PFAS Reduction Destruction Technology Pilot Evaluations through NPDES POTWS. Project is funded through capital funds for $2.9 million, and we have an additional $100,000 directed to Harvard through a Best Value grant, which is intended to help us account for all the PFAS compounds that are, present in the materials that are being sampled. The main portion of the grant was awarded to AECOM, who is partnering with CDM Smith, and that was began in December, and we're currently working with them to finalize the technologies that will be sampled as part of the piloting project, and finalize all of the sampling that will occur, and other details and logistics that are going into so that we can commence the study. That project will be completed by June 30th of 2026, and after internal review, we'll make those study results available to the public. Here's just an overview of the contents of the pilot project. The components include the pilot technologies, including reduction and destruction technologies, piloting locations at wastewater treatment POTWs that have a permitted discharge of at least 5 million gallons per day or more. The pilot inputs that are representative of the process stream where the piloting would be implemented at full scale. The sampling locations for both pilot inputs and the outputs, and then a fluorine mass balance and PFAS characterization evaluation that will be part of the final study. We're really trying to determine in these destruction and reduction technologies if we can account for the full load of the PFAS that enters the waste stream, and know that we're, can account for all of it at the exit stream. We have other MassDEP projects. Currently, we have undergoing internal review of redraft of regulation revisions for the land application of sludge regulations. That's 310 CMR 32. What we are trying to do is incentivize reductions in PFAS, and that set of regulations will be available for public comment when it is released, where it would be a robust public comment process in which we would review and respond to comments and make any revisions that were warranted as a result of the comments that we receive. We also have underway previous studies with USGS, the U.S. Geological Survey, for phase 1 and 2. That report development is currently underway, having completed the sampling in that particular report. And they are now undertaking phase 3, which is utilizing grab versus study to evaluate grab versus composite sampling. We have residuals PFAS database improvements that have been ongoing. We have a data system that receives PFAS results that labs are reporting for those of you who are, POTW operators. And we also have a public portal that makes those data available to the public after some quality assurance, quality control measures have been implemented for the data that we've received. We've been speaking at a variety of conferences recently, and we have upcoming conferences, the NUMOA conference in April of 2026 and the MOEA conference in May of 2026. Okay. I think at this point, I want to say thank you again to our consultants, Ty and Bond and Brown and Caldwell, who performed the sludge study parts 1 and 2 and the POTW study. And also, I want to say thank you for our current contractors, AECOM and CDM Smith, for a very positive collaboration that is underway with MassDEP. With that, we're going to enter into an open discussion portion of the meeting. Please enter your questions in the chat. We'll start at the top and work our way through them. We'll be posting this recording of the presentation, as well as answers to the questions, to our website following the meeting. If we have questions that we can't answer or need, conferral to be able to come up with a correct answer, then we will, skip ahead from that question and, address it when we attend the written questions and answers. So, we're starting at the top right with Mickey's question. Is that right?
Yes, I'm going to stop the recording first.
Yes, thank you.
Yeah, I can read